So if I look at this one, right? This column here, I know that it's the same thing as the square root of A. So basically what I did here, to get from here to here, I had to do the square root. Right? Now, if I want to go from this column, the second column, the square root column, to the third column here, if I do 2 times 2 times 2, that gives me 8. Or 2 to the power of 3, that gives me 8. 3 to the power of 3 gives me 27. 4 to the power of 3 gives me 64. So I've done the square root, but then I raised it to the power of 3. Do you see a 3 somewhere here? It's the exponent, right? So the bottom here, I know it's replacing the square root, okay? So I have a 3 over 2. I know that this denominator is replacing the square root. But then after that, what I'm doing is, I'm powering it to the power of 3. So if you look at this, the bottom is actually going into the square root, right, into the root, and then the exponent is making it to the power of 3. Let's see if that's true. What's 2 to the power of 5? 32, right? So I square rooted 4 to give me 2. Then I raised it to the power of 5. That gives me 32. Now, square root of 9 is 3. What's 3 to the power of 5? On your calculator, 3 to the power of 5. 243. Right? And guess what? 16, square root of 16 is 4. 4 to the power of 5 is 1024. Okay? So what's happening here is that the denominator is making it the root, and the exponent, the numerator, is your exponent. So there's 2 things happening here. You're doing the root and you're powering. Okay? Let's look if that's going to work with a cube. So 1 to the power of 1 over 3, that's 1. 8 to the power of 1 over 3, that's 2. 27 to the power of 1 over 3, that's 3. 64 to the power of 1 over 3, that's 4. Now, I'm going to guess the answer, and you're going to tell me if that's what you got or no. 1, 4, 9, 16. Right? How did I know that? Because I already have the cube root, right, which already takes care of this, and then I powered it to the power of 2. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Right? Let's see if I can do the next one. I think the next one is going to be exactly the same thing as this, no?
Yes.
132, 243. I'm not trying again. I'm sticking with my answer. Right? Why? Because I cube rooted already, so I have this already, and then I'm looking to the power of 5, right? To the power of 5. 1 to the power of 5 is 1. 2 to the power of 5 is 32. 3 to the power of 5 is 243. I've already done them here. And then 4 to the power of 5 is 1024. Now, is this going to work all the time? Yes, it is. Yes, it is. It's going to work all the time. Where when you have something to the power of, give me any power. Any power. Something over something. 7 over?
7 over 12.
Over 12. Okay. So, if I want to write this as a root, that's going to be the 12th root of A to the power of 7. about or Friday about exponent to the exponent. What do I do when I have power to the power? Times it. So what's 7 times 1 over 12? 7 over 12, right? Because I multiply top by top, bottom by bottom, right? So 7 over 12. Did I go back to what I started with? Did I go back here? Okay, so you see that no matter what the exponent is, the denominator is going to be in your root, right? So the denominator is going to go in your root, and then your numerator is going to go as your exponent. Okay, so let me go here. The denominator is going to go in your root, and then your numerator is going to go in your exponent. So I just want to explain something to you. So this format is called, just so I don't forget, this format is called rational exponent. And the reason why this is called rational is because your exponent is a fraction. And fraction, the name for fraction, the terminology for fraction is rational. Okay? Yeah, it comes from ratio. That's right. I'll tell you what the name of the other one. Okay, so let's write actually the formula. So what do you think the formula is going to look like? So if you have a to the power of m over n. The root of the nth root. A to the power of n. Okay? I can write it in two different ways. So I can write it as the nth root of a to the power of m as a outside. Doesn't matter which format you prefer. They both work. Okay? Now, this format, it's called radical exponent. Okay? So radical because this is what the root is. The root is a radical. This is called a radical. They're called radical numbers. Okay? Just so you know, if I ask you to go from rational to radical or radical to rational, this is what I'm talking about. Yeah. Of course. So let's compare. So compare the entries in the second, third, and fourth column of each table. How do the values of a to the power of 3 over 2 and a to the power of 5 over 2 relate to the values of a to the power of 1/2? We said that they're equal to a to the power of 1/2 and then to the power of 3 or to the power of 5, right? Raised to the power 3 Same with the a to the power of 2 over 3 and a to the power of 5 over 3. Compared to a to the power of 1 over 3, they're raised to the power of 2 and 5 respectively, right? So a to the power of 2 over 3 and a to the power of 5 over 3 are equal to a to the power of 1/3 raised to the power 2, and 5 respectively. All right. So you guys can finish the homework for this lesson.